This one will help you a lot. A liquid is having high boiling point will have low vapor pressure. A liquid is having low boiling point will have high vapor pressure. So, nature of the liquid determine very clearly that which substance will have high boiling point, high vapor pressure, and which substance will have low vapor pressure. Second is there, that is temperature. Temperature also plays a vital role in deciding the vapor pressure. Now suppose same container you have, beginning first time you have taken water, second time you have taken alcohol, and third time in same container we are giving now again water. Alright, and now we heat it. Now we give the temperature. We see in beginning time we got the vapor pressure in 30 minutes. Second time we are getting the vapor pressure in 10 minutes. Why? Because liquid will start to boil quickly. And once boiling will be there, the enrichment of the vapor pressure, enrichment of the formation of vapor will be very high. Alright? So vapor pressure will get more and more when you heat the solutions. So in this way, you have understood very clearly that what is the concept of vapor pressure. Why do I give more and more stress on vapor pressure? Because in solution, the 90% of the material is related to vapor pressure. Alright? Now, after this vapor pressure, we are coming to that this vapor pressure plays a very vital role, and one scientist, that is your Raoults, gave a significant information, an excellent information regarding the vapor pressure, regarding the solubility of a non-volatile substance to the volatile solvent, etc. Alright? So you will see the whole solutions of various type of approach we are getting regarding the vapor pressure. Now see, Raoults, a scientist who gave an excellent, immense information regarding the vapor pressure. Raoults gave one relationship, that is PA equals to P naught A XA and PV equals to P naught B XB. For what? For binary solutions. For binary solutions. What do you mean by binary solutions? Binary solutions means a solution which has two components. A solution is having four components, tertiary solution, quaternary solutions. A solution is having three components, tertiary solutions. So for binary solutions, what happens? Name of the scientist is Raoults law. Raoults says, please concentrate on this one. You understand what Raoults says? Raoults says, this is your mathematical expression of Raoults, that PA equals to P naught A XA and PV equals to P naught B XB. Suppose first relationship and second relationship. Same Raoults law say. Now, if you want to give the words for this one, then we say the partial vapor pressure of a component will be equal to the product of its vapor pressure and its mole fraction. It means PA and PV equals to partial vapor pressure of component A and B. P naught A and P naught B, that is your vapor pressure of component A and B, and XA and XB equals to the mole fractions of component A and B. This is the Raoults law. This is the form of Raoults law in words, and this is your form of Raoults law in mathematical form. Alright. And now Raoults simply is not limited up to this one. So many things was told by Raoults. This is the one approach of Raoult. Alright. Okay. What is the second approach of Raoults? The Raoults told, in the second form of Raoults told, that next approach of the Raoult told that delta H mixing equals to 0, and next approach of Raoults, that is delta V mixing equals to 0. What do you mean by delta H mixing and delta V mixing? Delta H is your enthalpy. Alright. Delta H is enthalpy. What is enthalpy? Heat content at constant pressure. That constant pressure means atmospheric pressure. Heat content at constant pressure, that is your enthalpy. Heat content means H equals to E plus PV, sum of enthalpy and pressure volume work. See here. Now delta H mixing equals to 0 means the change in enthalpy upon mixing is coming 0. It means when the component A and B are mixed together, see, there are two components A and B. When both the components are mixed together, at that time neither energy is released nor energy is absorbed. This is called delta H mixing equals to 0. Same way, delta V mixing equals to 0 means what? See, delta V mixing means change in volume upon mixing. Change in volume upon mixing is represented as delta V. So in delta V what happens? Suppose component A we have taken 100 ml, component B we have taken 100 ml, 100 ml plus 100 ml, its volume is coming 200 ml. It means delta V mixing equals to 0. Neither increased nor decreased. Neither volume is increasing nor volume is decreasing. It is understood thing is there that when you will take 100 ml plus 100 ml, volume will be 200 ml. So this 200 ml, we say in this form, in the terms of Raoults law, delta V mixing equals to 0. A question arises, is 100 plus 100, 200 will be there. What is extra thing here? In the same discussion you will find that when 100 ml plus 100 ml we will add, in some cases, sometimes it will be less than 200 ml and sometimes it will be more than 200 ml. Did you understand? That's why we say that here 100 ml plus 100 ml equals to coming 200 ml. It is not a simple thing. It is a very great thing because we discuss in terms of Raoults law. And just after some time it is going to be same thing when we will mix. The volume will be either more than 200 ml or less than 200 ml. Alright. So in this context, it is very essential that 100 plus 100 when it is coming 200 ml means delta V mixing, that is change in volume is coming 0. Once more, delta H mixing means change in enthalpy upon mixing is 0, means neither energy is released nor energy is absorbed. Delta V mixing equals to 0 means upon mixing of the equal volume of substances, neither volume is increased nor volume is decreased. Now, what happens? After Raoults law told these things. When Raoults law told these things, then simply you will say that yes, I have told these things and you will not prove it, then your statement will be simply a hypothesis. If you have to prove it that yes, whatever I say, whole world will accept me, then this will be rule, this will be law. Then Raoults showed the experimental proof also. Alright. Raoults showed the experimental proof. How did he show the experimental proof? You see, he has taken the example of hexane C6H14 and C7H16. This is your normal hexane, this is your normal heptane. When he mixed normal hexane and normal heptane, he proved that this hexane and heptane follows this thing, Pa equals to P0 AXA, Pv equals to P0 BXB, and delta H mixing equals to 0 and delta V mixing equals to 0. Not only in this case, He took another example. He took C2H5Br and C2H5I, ethyl bromide and ethyl iodide, and again he found the same thing. So he didn't simply speak, he proved it by taking various examples. He did not make him limit up to this one. He gave another example. He take another experiment. What did he do? He has taken C6H5Cl, chlorobenzene and bromobenzene, C6H5Br. In that one also he found the same thing. So Raoults told that if a mixture of solutions, if a binary solutions is showing such type of things, then such type of solutions are called ideal solutions. So these are the examples of ideal solutions. These are the example of ideal solutions. Ideal solution means ideal solution will obey or will follow PA equals to P naught AXA, PV equals to P naught VXB, delta H mixing equals to 0 and delta V mixing equals to 0. Are you getting me? So in this way, what happens? It was the credit of Raoults law that he told us, he proved, he gave a new contribution to us, that is ideal solution. Before that one, the whole world was not knowing what is ideal solution. Alright. And afterwards, Raoults did not limit himself up to this ideal solution only. He told there are so many solutions which do not obey such type of things. Whatever I have told, they do not obey such type of things, and that type of solutions are called non-ideal solutions. Did you understand? That type of solutions are called non-ideal solutions. So, what are ideal solutions that we have seen? These are ideal solutions, ideal behavior, ideal approach, ideal conditions, and then what will be the non-ideal solutions? In non-ideal solutions, see, complete this one.